Dear students, in this lecture we are going to see design of lead commutator using Bode plot. So we will follow the design using step-by-step process. We will start with, so if you are given a problem, we have to find the unknown value of k. The next step is to replace s with j omega. Next we can solve easily using calculator method. So in calculator we can press more and we can enter into complex mode. And again we have to need to change one thing, that is replace j with I, since the calculator does not have a j tab, and omega should be replaced with a. And again we have to replace the order of I and a as ai, because the calculator will not accept this form. Next we have to find g of j omega, which can be found as 20 log of abs of g of s, and the phase and phase margin can be found as phi is equal to argument of g of s, where g of s is the given uncompensated system. So next step is we have to prepare a table with omega, g of j omega and phi as follows. So here we have to take the omega value from 0.01 and till 100 we can make a tabular column. We have to find the gain, where we are getting the gain value as 0 and phase value as gamma at the frequency omega pc. We have to find that value. So that is step number 4. We have to find gamma at phi omega is equal to omega pc, and we have to, using this formula we can find value of phi l is given by phi l is equal to phi s minus phi pm plus epsilon. So phi s will be given in the problem, and assume the value of beta between 1 to 50. The phi l relation is given as phi pm is equal to 180 degree plus gamma. From that we will be able to find phi l. So next step is we have to find the alpha value, which is given by 1 minus sine phi l, sine phi l divided by 1 plus sine phi l. Next we have to find 10 log of that alpha value. Next we have to identify a frequency at which the gain GUC of the uncompensated system is equal to minus 10 log 1 by alpha. How we will find this? Again we will make a table, and having a omega value from 0.001 to 100. So we will find an gain value which is equal to minus 10 log 1 by alpha, and to that corresponding value we will get an omega value, that is omega m, that we have to identify. After to identify that, we can use the formula tau, which is given by 1 by omega m into root alpha. The basic formula is omega m is equal to 1 by tau root alpha. So using that we will be able to find the value of tau. If you are able to find the value of tau, we can find the gain of the compensator system as alpha into s plus 1 by tau divided by s plus 1 by alpha tau, which is equal to tau s plus 1 divided by alpha tau s1 plus 1. So by this we can find the gain of the compensator system. Now we will see this using an example. A unity feedback system has an open loop transfer function gf of s is equal to kv by s into s plus 1. Design a suitable lead compensator to meet the following specification. The static velocity constant is 12 seconds per minus 1 and the phase margin is 40 degree. So we are given the value phi s phase margin 40 degree, and the constant static velocity constant kv equal to 12 seconds per minus 1. So we can find that value of k by using the formula. Kv is equal to the formula for kv as limit s tending to 0 s into gh. So equal to limit s tend to 0, s into k by s into s plus 1 divided by s into s plus 1. So s is get cancelled and we will be able to find the k value as 12. So now we will substitute the k value in the uncompensated system. G u c of s equal to 12 by s into s plus 1. And now we have to find the k g of j omega equal to 0, and we need to find the corresponding phase angle gamma. So it will be for a value of omega equal to 3.4 radian per second. So using that value, we are going to proceed further. Now we have find the gamma value at gamma 5 omega is equal to omega pc. That is at the point where the gain margin is 0. So the gamma is equal to minus 163. So we know a formula 5 pm is equal to 180 plus gamma. From that we will be able to find the 5 pm, which is equal to 180 plus gamma is equal to 17 degree. Next we will find the phi L, which is equal to phi s minus 5 pm plus epsilon. So the phi s value is given in the problem for our design. The 5 pm we have calculated as minus 17. So 40 minus 17 plus epsilon, the assigned value, which will give us 33 degree. Next we have to find the value of alpha. So alpha is equal to 1 minus sin phi m divided by 1 plus sin phi m. So which when we substitute the 33 degree, we get alpha value is 0.27. Next we have to find 10 log of that alpha value. So which gives us 10 log of 0.27, which gives us 5.67. Next we have to identify a frequency at which we are getting the gain values uh, minus 10 log of 1 by alpha, that is minus 5.67. So using the table we will get the value at omega n is equal to 4.75 radians per second. We know the formula for omega m. Omega m is equal to 1 by tau root alpha. So using that formula we can find the value of tau is equal to 1 by omega m root alpha. So when we substitute the value, we get the value is 0.4. From we have known the value of alpha and tau, we can substitute that in transfer function. Gc of s equal to alpha into s plus 1 by tau divided by s plus 1 by alpha tau, which is equal to tau s plus 1 divided by alpha tau s plus 1, which is equal to 0.4 s plus 1 divided by 0.108 s plus 1. We can plot this value using MATLAB. We'll take numerator polynomial value and denominator polynomial value. As numerator is equal to 12, denominator is equal to 1, 1, 0. So from that we are finding the transfer function. So GU is equal to PF of NM1, comma, denominator DEM1. So next we have to plot the Bode plot using Bode of GU. Next, since we need to plot the effect before compensation and after compensation, we are using the function called up. So NEM2 value are entering at 0.4 and 1, denominator 2, so that is DEM is equal to 0.108 and 1. So this is the compensator system. So we are finding the transfer function of compensator system. Gc equal to transfer function of numerator 2, denominator 2. Next we are plotting the Bode plot. So as a combination of both, since that will give the compensator system, and we are plotting that in the graph. So we can find that the blue color represents the uncompensated system and the red color represents the compensated. So we can find the system before compensation as well as after compensation. Also we can do this problem using Python and we can plot the problem. So from SkyPy we are importing signal. So for doing Boston. Next, we are importing matplotlib.py plot as PLT. So this is for drawing plots. So next, like in the case of MATLAB, we are rendering the uncommon shaded system, and we are converting it into transfer function using g equal to signal dot lpi of numerator 1 comma denominator 1, and we are plotting the getting the value for the omega magnitude and phase using signal dot Fode of GU, and likewise we are formatted num2 and print2. So this is a combination of compensator as well as the uncompensated system, and the LT system for that is generated using DC equal to signal dot LTR num2 then 2. Next we are plotting the Bode plot and getting the response of W1, uh, that is omega and magnitude mag 1 and phase base 1 equal to signal dot Bode of DC. Next we are plotting the figure, that is the PLT of figure. Then we are plotting the similarity between omega and magnitude, and next we are plotting the similarity between omega 1 and uh, mag 1, that is between compensated system and uncompensated system. Next we are labeling the values magnitude plot, and we are giving a type plus Bode plot. This is for the first plot, that's the magnitude plot. Next we are going for the phase plot. For that we are using ELT dot figure of ELT dot semilog x of omega comma phase for the uncompensated system, and ELT dot semilog x omega 1 comma phase 1 for the compensated system, and ELT dot x label for labeling the x-axis, and we are labeling the y-axis as face block. Next we are giving us PLT dot show to display the result. So we can do this both by using MATLAB and the Python.